Welcome back to the Deep Dive. Today, we are strapping in for uh, a pretty serious cosmic journey.
We are.
But this isn't a deep dive into, the physics of black holes or anything like that. We're getting into the chilling logic of astrostatistics.
And the philosophy of collapse.
Exactly. We are tackling what is maybe the single greatest mystery of the cosmos, the silence.
That's right. And our source material for this is just extraordinary. We're analyzing excerpts from Stanislav Lem's monumental 1964 work, Summa Technologiae.
Which is often overlooked, I think.
Totally. Specifically, we're in Chapter 3, Cosmic Civilizations. And you have to understand, this isn't science fiction. It's a really rigorous philosophical and statistical treatise. Lem is synthesizing the foundational arguments from pioneers like Bracewell, von Horner, and Shklovsky.
And he's using them to address this staggering gap between what we expect to find out there and, well, what we've actually observed.
Which is nothing.
Which is nothing. So, okay, let's unpack this. Our mission for this deep dive is clear. We want to understand the foundational arguments against widespread, long-lived galactic empires. And for you listening, this is your shortcut right to the statistical heart of the Fermi paradox.
Right, that enormous gap between where the numbers say intelligent life should be.
And the total deafening silence that we actually hear.
Lem's framework, it forces us to move past the simple question of, is there life out there, and toward a much more profound and, frankly, uncomfortable question.
Which is?
If high intelligence arises frequently, why does it seem to vanish so quickly, or what does it transform into? We're basically asking, what's the average lifespan of a technological society?
The central puzzle is just terrifyingly simple when you boil it down. Life evolved here on a pretty average planet orbiting a stable star.
A very normal G-type star.
There are billions of other stars offering similar platforms for billions of years. So why is the galaxy so quiet?
We have to explain it. We have to reconcile the theory, which suggests a galaxy packed with vibrant civilizations with the total lack of observational data.
No signals, no probes.
And definitely no astro-engineering miracles, as Shklovsky called them.
To do that, we have to start by throwing out our most comforting assumption. The one that says intelligence, once it gets going, is stable.
That it's persistent. The silence itself demands we change that one variable, the longevity factor. It has to go.
All right, so let's start there with that statistical clash, because it's really that initial assumption of longevity that creates the paradox in the first place.
It is. When the early thinkers approached this problem, they started with what seemed, like the most intuitive hypothesis.
That once you make it, you're here to stay.
Pretty much. The starting hypothesis is that a civilization's potential lifespan is comparable to its parent star's lifespan.
Billions of years.
Billions. Our sun is stable for billions of years, so a successful civilization, logically, should be able to last for billions of years, too.
Okay, so let's accept that premise for a moment. If civilizations last for billions of years, what does that inevitably mean for galactic population density?
Well, the implication is staggering. It inevitably leads to the conclusion that the density of cosmic civilizations should be extremely high.
And we're not talking thousands of light years apart.
No. We're talking about two inhabited, technologically advanced worlds being separated by only a few light years.
A few light years. That's our next door neighbor. Proxima Centauri is 4 light years away.
Exactly. We'd be sharing the same local star cluster. And if that were true, the sky, even to a basic radio telescope, would just be humming with activity.
Right. The communication delays would be, a few years? The galaxy would have been colonized eons ago.
And yet, this statistical conclusion is strongly, powerfully contradicted by all observations.
And Lem notes this isn't just one contradiction, it's a 3-pronged failure.
Right. The silence isn't just one type of failure to detect something, it's 3 different failures, all happening at the same time.
So let's detail those, because they really define the problem we're trying to solve. The first one is the one everybody knows.
The first failure is the negative result of listening in on the universe.
SETI.
All the SETI experiments. Decades of systematically searching with radio waves, looking for intentional signals, or even just, the technological leakage our own civilization pumps out.
And we've found
nothing. No definitive evidence of anyone deliberately communicating or even accidentally revealing their presence. 0.
And the second failure goes beyond just listening. If civilizations are that close and live for billions of years, they wouldn't just be talking.
They'd be moving. The second absence is the lack of other, more tangible signals, like alien rocket probes.
Bracewell probes.
Exactly. The mathematician Ronald Bracewell hypothesized these highly autonomous robotic emissaries that would be designed to wait patiently near habitable planets.
We see none of them.
Yeah,
No evidence of them ever visiting our solar system.
not a shred. And the third absence, this is the one that really gets me. It sets the scale of this missing galactic empire. It's the complete absence of what Lem calls miracles.
Phenomena caused by gigantic astroengineering activities.
Right. This is where that billion-year longevity assumption really, really breaks down.
Because a billion-year-old civilization wouldn't just be building cities.
No, we are talking about stellar-scale projects, things we can barely imagine. Dyson spheres or Dyson swarms designed to capture every single joule of energy from their parent star.
We'd expect to see deliberate, unnatural alterations of astronomical bodies, mining entire planets, restructuring nebulae.
These miracles should be visible across vast galactic distances. You could see the heat signature of a Dyson sphere from another galaxy, and they'd be visible even if the civilization itself died out millions of years ago.
So the silence isn't just a lack of chatter. It's a lack of any physical evidence that anyone has been active on a galactic scale, ever.
And since that original assumption fails so spectacularly, we have to change the variable.
The longevity variable.
So, to reconcile this massive statistical contradiction with the harsh reality of the silence, thinkers like Bracewell, von Horner, and Shklovsky, they all adopted what we call the shift to ephemerality.
They proposed that civilizations, relative to their stars, are incredibly short-lived.
It's the only...
The short life hypothesis. This is the only way you can thin the herd enough to explain the silence, to create that distance.
And you can see how drastically the numbers change as you shorten that lifespan. Let's start with a medium-term calculation.
Okay.
Let's say the average lifespan isn't billions of years, but only 100 million years. Still an immense amount of time for us.
100 million years. What does that do to the distance between civilizations?
It pushes them out to about 50 light years, statistically.
50 light years. Okay, that's still pretty close. Close enough that we should be able to detect them. And in 100 million years, you'd think they would have colonized everything nearby.
Exactly. So even 50 light years is still considered, as the source notes, highly doubtful for explaining the paradox. It doesn't get you all the way there.
So we have to go shorter.
We have to go much, much shorter. To truly align the theory with what we observe, we have to move to the short-term calculation. We have to slash the average duration of a civilization to just a few thousand years.
A few thousand.
Maybe a little more than 10,000. It's a radical step, but it's what the logic demands.
And when you accept that extreme ephemerality, that civilizations are just these fragile, temporary flashes in the pan, what does that do to the separation distance?
That's when you get a number that finally makes sense. The two nearest highly developed worlds would be separated by a distance of around 1,000 light years.
1,000 light years. And that is the key insight.
That's the number.
Because 1,000 light years makes the observational failures.
Yeah.
It makes them understandable. The failed listening in, the failed observation of any physical structures.
Right. If your neighbor is 1,000 light years away and they only live for, say, 10,000 years, the chance that their on-time overlaps with our listening time is incredibly small.
We're looking for a flash in a cosmic pan that's separated from us by this immense gulf of space and time.
Precisely. And we have to remember the sheer scale of the input numbers here. The paradox isn't that life is rare.
No, it's that intelligence doesn't seem to last.
The estimates used in these analyses are very generous. The one discussed here suggests that out of 150 billion stars in our galaxy, about 1 billion of them have planets suitable for life.
1 billion potential cradles. That's a huge starting number.
And this is so critical to grasp. Lem's analysis says the problem is so vast that even if you reduce that estimate of life-bearing planets by a factor of 10,
So only 100 million.
even then, it doesn't significantly change the results. If civilizations lasted for billions of years, they should still be everywhere.
The numbers are just too big.
They're too big, so the only way the statistics can be reconciled with the observational silence is to assume a catastrophic, rapid collapse of virtually every intelligent society almost as soon as it achieves advanced technology.
So we've solved the statistical clash, but we've replaced it with a profound philosophical crisis. Why is high intelligence so exquisitely fragile?
And that brings us directly to the core challenge here, the great mystery of collapse. Lem adopted the term psychozoa to describe this cosmic phase.
The phase of advanced intelligent life and its technology.
Yes, and it's such a powerful term because it elevates this technological phase into a new geological or cosmic era, which makes its rapid collapse all the more shocking.
If the evolution of life in its pre-civilization form, that takes billions of years.
Millions.
So why must the Psychozoa, this magnificent start, perish in just a few dozen centuries?
It's the radical discontinuity in the timescales, the star. It provides continuous energy for billions of years. The evolutionary ramp-up from microbes to intelligence takes billions of years. It's a slow, steady, stable process.
And then the end product, the intelligence, is seemingly destroyed almost instantly, cosmologically speaking.
Instantly. Even if a civilization lasted for 1,000,000 years, that's still a microscopic fraction of the time their star gives them. So the collapse it's mysterious, as Lem says. It's wholly disproportionate to the stable environment that created it.
Which suggests the real great filter isn't the origin of life. It's the stability of intelligence itself. The jump from an intelligent society to a long-lived one seems to be the hurdle almost no one clears.
And since observation demanded that 1,000 light-year separation, von Horner just accepted the ephemerality of the psychozoa as a fact that needed an explanation.
So he tried to figure out why.
He tried to create a taxonomy of universal catastrophes. He came up with 4 possible causes.
Okay, hold on. Why 4? I mean, why did he feel the need to invent 4 distinct categories? Couldn't total annihilation just cover any kind of disaster?
That's a great question, and it really speaks to the depth of his analysis. He was trying to cover the entire spectrum of existential risk. He wanted to separate external causes, self-inflicted ones, slow internal decay, and even philosophical causes.
Okay, so let's walk through his 4 causes for collapse. What's the first one?
The first one is the most final. Complete destruction of life on the planet.
Total sterilization. A gamma-ray burst, runaway climate change.
A technological error so catastrophic it renders the planet uninhabitable. The slate is wiped clean. The planet is dead.
And the second cause is more specific.
Yes. The second cause is destruction of only the highly developed beings. This implies a selective catastrophe.
So a nuclear war, a tailored bioweapon, a rogue AI. Something that only targets the complex society and its intelligent members.
Exactly. The planet remains biologically viable, lower life forms survive, the cosmic cradle is still intact, ready for another long climb up the evolutionary ladder, but the psychozoa phase is over.
So we go from planetary annihilation to societal self-destruction. What about the slower ways to die?
Cause 3 is psychic or physical degeneration. This is a profound internal collapse.
Rooted in biology or sociology?
It could be a failure of the species due to, say, over-engineering its own genetics. Or maybe a deep societal malaise. They solve all their problems, lose their evolutionary drive, and just sort of decline mentally. They become incapable of maintaining their own technology.
That one is really chilling. The idea that intelligence might just break down under the weight of its own success. They don't die in a flash of light, they just fade away.
And the fourth cause von Horner proposed was loss of interest in science and technology.
Apathy as an extinction event.
You could see it that way. It's a cultural transformation, a complete redirection of civilizational energy. They might achieve some state of inner contentment, or their philosophical interest just becomes so dominant that they stop caring about physics experiments or sending probes. Galactic activity becomes meaningless to them.
So regardless of the mechanism, from annihilation to apathy, they all result in the civilization leaving the observable stage.
They vanish from the window of contact. And von Horner, by assigning probabilities to these 4 fatal factors, he calculated a very specific and very sobering estimate.
For the average duration of a civilization in this technological stage?
Yes. His number was 6,500 years.
6,500 years. That's barely longer than recorded human history. It's just a cosmic heartbeat.
And that brief existence is the only way to statistically justify the 1,000 light-year separation needed to explain the silence.
So those two numbers are linked.
They are inextricably linked. 6,500 years and 1,000 light-years. They define the probability space of the Fermi paradox as resolved by this short-life hypothesis.
But this is where the logic becomes just profoundly depressing for anyone hoping to find, our peers out there. The contact implication.
It's negligible. Think about where we are now, Earth in its technological infancy. The calculation shows that the probability of us making first contact with civilization in the same phase of development as us
True contemporary.
is only 0.5%.
0.5%.
Right.
So the whole premise of searching for a mirror image of ourselves right now is statistically just a fantasy.
It's a needle in a 1,000-light-year haystack that only exists for 65 centuries. The odds are overwhelming that if we detect a signal tomorrow, it won't be from a civilization like ours.
Right. It'll be from someone much older.
Much older. The calculation showed that the most probable age of the civilization, we do contact first.
What was it?
12,000 years old.
12,000. So nearly twice the statistical average.
Which means if we do contact someone, they're almost certainly an outlier. A society that has somehow managed to survive whatever existential risk destroys the average civilization.
And that age difference implies a vast, maybe incomprehensible gulf in knowledge and philosophy.
They've solved at least one of von Horner's 4 causes. They're the exception that proves the rule of cosmic fragility.
But even they, at 12,000 years old, still don't explain the complete silence of the galaxy over billions of years.
Not at all.
Okay, so if the statistics of ephemerality are right and we're separated by 1,000 light years, that distance itself creates a huge barrier.
An almost insurmountable one. The first thing it does is make the failure of our early search experiments completely understandable. We weren't looking far enough away in space or far enough back in time.
And it creates this profound time delay problem.
Right. If we established a connection today with that 12,000-year-old civilization 1,000 light years away,
We send a message, hello,
the answer would take 2,000 years to get back to Earth.
2 millennia for a single reply. That's
Yeah,
that's not a conversation.
It's not. It makes any kind of collaboration or shared learning totally impractical. Your great-great-great-great-grandchildren might get the reply to a question you asked. By then, your entire civilization might have collapsed.
You can't warn someone about a looming disaster if the warning takes 1,000 years to get there. It just condemns every civilization to this isolated short life.
It does. But von Horner introduced a fascinating theoretical escape route. He called it local thickening.
You didn't assume total isolation was mandatory.
No, he allowed for statistical variation. What if, just by sheer chance, a little cluster of cosmic civilizations emerged close to each other? A local thickening of the psychozoa.
So a lucky little neighborhood in the galaxy where civilizations are maybe only 50 or 100 light years apart.
Exactly. And a key condition for success there is simple. The time it takes to get an answer has to be short compared to the lifespan of the civilizations.
If they're 50 light years apart, a round trip is 100 years. If your lifespan is 6,500 years, you can have 64 back and forth conversations.
That's meaningful dialogue. That's effective information exchange. They could share scientific knowledge, pool resources, warn each other about common dangers.
And that mutual support could prolong their existence well beyond that 6,500-year average.
And this concept was then massively expanded on by Shklovsky. He likened this positive feedback process to the avalanche-like reproduction of organisms in a favorable environment.
So this cluster doesn't just survive. It spreads its stability.
It draws in an increasing number of neighboring civilizations, leading to the creation of a kind of superorganism,
A unified, hyper-intelligent galactic entity.
defined not by biology, but by shared communication and a shared purpose. It would effectively bypass all 4 of von Horner's causes for collapse.
Right. Shared knowledge prevents stagnation, mutual defense prevents local failures, and a grand goal would prevent that loss of interest. It should be incredibly long-lived.
Millions, if not billions of years.
Which brings us right back around to the silence and the ultimate unsolved mystery. If this process is scientifically sound, and statistics says that some civilizations must have been close enough to start it,
The most astonishing and incomprehensible part is why this superorganism has not yet been realized in our galaxy.
or at least not in an observable way.
Right. If it existed, it shouldn't just be obvious. It should be the dominant feature of the galaxy. This is the source of all those missing miracles.
Its failure to appear is maybe the most powerful argument against the entire short-life hypothesis, which forces us to look for another explanation entirely, beyond simple destruction.
We have to confront the deepest statistical hurdle now, the one that directly contradicts von Horner's own conclusions.
We've accepted that the average lifespan is 6,500 years, but that can't be a universal fatal rule for every single civilization.
No, because that's not how statistics work. If you assume that out of 1 billion potential civilizations, not a single one survives for, say, 1 million years, That's not statistics anymore.
It's a
That's
curse, a mysterious fatal determinism, as Lem puts it, a devilish insistence on rapid destruction.
exactly. Statistical necessity demands that some civilizations must endure for millions of years.
Ugh.
Even if the probability of success is 1 in 1,000, given the huge numbers and timescales, the outliers, the long-lived ones, have to exist. The probability of 0 successes is basically 0.
And these long-lived civilizations, these survivors, they would have had millions of years to master vast stellar spaces. They wouldn't be confined to their home planets.
No. They would be the galactic dominators. Their presence should have become the determining factor in galactic development. The superorganism should have become a reality thousands of centuries ago.
But again, we are back to the silence, which forces us to revisit that catalog of missing phenomena. But this time, we're not asking why 6,500-year-old civilizations aren't visible. We're asking why these million-year-old galactic dominators are silent.
We have to ask, why are their actions not apparent? They've had millions of years to build transmitters, so why are there no signals from them?
Why no manifestations of their gigantic astroengineering? Where are the Dyson spheres? The absence of these megastructures is the strongest argument against their physical presence.
And the probes. Why no countless information probes piercing the cosmos? The self-replicating von Neumann machines that should have reached every corner of our own solar system long ago.
So the ultimate question remains, why do we not observe miracles? The universe looks exactly as if intelligence never evolved anywhere but here.
Or that the few successful ones adopted a universal policy of absolute profound secrecy, which seems unlikely.
So if von Horner's 4 causes aren't enough to explain this total silence from the statistically necessary long-lived civilizations, we have to consider the alternatives to destruction.
Right. What if they don't die? What if they change? In a way that removes them from our observational window?
Alternative 1, the missing 5th cause. The idea that a civilization changes so fundamentally that it just leaves the window of contact.
It ceases to be an intelligent community in any way we would understand it. They no longer use radio waves or rockets or stellar-scale engineering. They transform into a cosmic force.
A state of existence that is just beyond our technological comprehension.
It's almost a religious argument. The ultimate success looks exactly like a vacuum to us. Their interests, the physics they use, it might transcend the observable universe we inhabit. They could be post-biological, existing as pure energy or data.
It's a wild idea. And then there's alternative 2, which takes it a step further.
Alternative 2, which is associated with thinkers like Werner Vinge, argues that this transformation into a force is not a statistical accident. It's not something a few lucky civilizations achieve.
It's what happens to everyone.
It is the natural result of the development of every civilization.
So the 6,500-year lifespan isn't when they die. It's when they transcend.
Exactly. Every civilization, upon reaching a certain technological or philosophical threshold, the singularity, maybe automatically evolves out of the communicative stage. They leave the window of contact.
And the consequence of that is just intellectually chilling.
It is. The galaxy is silent not because intelligence is rare or self-destructive, but because it's so wildly successful that it inevitably sheds the physical, material concerns that we rely on to detect it.
The superorganism did form, maybe many times over, but it became something we can't perceive.
It's playing a different game on a different plane of existence. The silence, in this context, isn't the quiet of the graveyard.
It's the quiet of the unfathomable. So let's try to synthesize this whole journey. We started with the optimistic idea of neighbors just a few light years away.
But reality, the silence, forced us to accept von Horner's short life hypothesis, which led to that brutal necessity of a 1,000 light-year separation and a tiny 6,500-year average lifespan.
And that statistical ephemerality creates the 2,000-year communication delay, making any real dialogue impossible and raising the mystery of why a superorganism of long-lived intelligence hasn't appeared.
Or, if it did, why it left no trace of its titanic engineering.
And the search for those missing miracles, the Dyson spheres, the probes, forces us to consider that the few civilizations that must have lived for millions of years didn't crash and burn.
They just stopped needing the physical universe in a way we can see.
I think the most valuable insight here for you, the listener, is that the search for extraterrestrial intelligence, it's less about finding life and more about understanding the instability of intelligence itself.
The psychozoa is temporary. It either collapses internally, or it transitions into something so unrecognizable that it leaves our window of contact entirely.
Which leaves us with a final provocative thought to chew on. If that transformation into a cosmic force is the natural inevitable end state for all intelligence, then the silence we observe is not the silence of the graveyard.
It's the silence of the unfathomable.
If true success means stepping out of the physical arena entirely, what happens to a civilization when its interests transcend science and technology as we know them? Perhaps the absence of miracles is the only possible miracle that truly successful intelligence can produce. That is the thought to mull over.